So we were talking about ResNet, right? So um, I guess of course maybe you guys like to use like TensorFlow and so on. It would be the same, or even Cafe. Um, there's a Cafe started that I have this so-called model zoo. That like have like lots of model that but nowadays I don't know like uh I mean like all these model zoo like you for I mean like for all these like packages like MXNet like TensorFlow Keras like PyTorch, all of them like should be able to access the model zoo. And also like for PyTorch like they have lots of model already like pre-trained, and then like, it's available. For example, like if I look at the Torch Vision, like the current version is like 0.9 something. If you just want this list file, you can see what kind of models they have already. Maybe I will put one of the homework, like just you guys take several models and compare, run some experiments. So and here is a ResNet example. So I just uh, kind of load ResNet here, like Torch, and then load ResNet. This is like from the Torch Vision, like the zero point 0.9 version, the current version, and it's like ResNet 18, not very big. It's like taking the pre-train one, and this can show the model. Like maybe I just want it anyway. Let's see. So this will show the model. Um, I will later on show you use the tensorboard. Tensorboard would be like more kind of like visualized to see the model itself. So, but like you can just here like to with the entire model, and you can see like each of the layers. I say this is has a layer one. Layer one inside have the sequential, have the basic block inside that. It's hard to kind of like read like this. I think like we'll come back to that later on. And then like okay, this like let's test on just an image. Right, I have an image of a dog. So and it's have the URL like here. It's a URL and the file name, and then I can retrieve that. So retrieve the file name here from the URL. Um, so if the I will just use image open to open that. Like image that one you will need to use the Python image library. So uh, I forgot how you install this. Every time I need to Google that. Like if you're interested, you can just Google that. So and so here like did a little pre-processing because I for to match with um the model like the setting like Westlight was trained at that moment. So this I just say match with like say the dimension, also like how it's normalized the intensity and the variance. So you can see like here already showing this is like basically the original image and also like the uh, cropped and also normalized image. So it's center crop to this one here. Actually, I may not need to center crop. Maybe I can resize it. I don't know. So resize center crop. Okay, anyway. So and the size of the image, you can let's see what's the size of the image. So I have the image. Um, I'm also okay. You can see like I process the image into a tensor, and then I create this a batch. So it would be like a single image batch. You can see the dimension of that like uh, it's like this way. So single image, I mean it's like 224 by 224. And unlike like for example like if you used to like OpenCV and Torch, right? Yeah, OpenCV, then like particularly you have the third dimension is the color channel you have here, but instead like the convention will be like first the channel, like which channel, like the first index. If I ignore this, is like the first index should be the batch. So batch I mean the image number inside the batch, and then the second one will be like the color channel, and then then this will be the dimension. Um, Now then I can put this into the model, eh? So I use the GPUs here, see if like GPU is available. So I have like, so you can see like, if I want this one, you can see I was device here. So device is CUDA. It's like if CUDA is available, it's CUDA. Otherwise, we'll be using CPU. So then I should put my model in CUDA, so into the GPUs. So that will create a model to basically put the model into the GPU. And then because I'm doing evaluation, I don't want to do the backpop. So I will tell Torch not to compute the gradient. So with no gradient here, model input, like here, like I need to be careful. Like if I don't have this, I will have bugs here. So this always, I don't know how about like for TensorFlow carrots, but for PyTorch, it's very easy to move things around from CPU and GPUs. And you cannot mix them. Like you cannot have, for example, like have the model like on the GPU and try to process data on the CPU. They have to be in the same place. So you can see they are complaining basically that also like, let's see, it's something like saying that like the input is like on full tensor, right? Full tensor will be on the CPU, but the weights are on the GPU, like torch, like torch CUDA full tensor. So therefore they should be in the same place. So then like if here, like if I have this like two device, then everything will be good. And then I have a pinout output here. This output, I just have one image, right? So it will be like just evaluating first image and have all the probabilities here. And then I have the probabilities here can go for softmax function and pin out the okay, and pin out the probabilities will be like below. Actually, like this would be the probabilities. Then I can download the labels here from the image class, image-led class, um, and uh, and the labels. Open the labels here and call them categories. And Torch have a top K kind of function, just like get the top K numbers from this vector probabilities here. So I want top 5 here. So I take the top 5. I get the top 5 probabilities and then top 5 categories. And for the top 5 here, we'll just pin that out. Uh, so you see like that. It's very accurate. I classify in a summary. So how do you pronounce that? I'm not so sure. I'm not really a doc person. So I'm here like here I'm showing like it's very easy like to also write the model into like TensorBoard. I can import the summary writer here and then writer. I just need to give a name for this. Like I'm not sure I can do it because I run it before, so I'm not sure it knows to override or whatever. So this will be just a folder name, and then I should add the graph with the model and also with the input of the model. So then I should I'm good to go. So then I should, if I go to let's see, if I go to, or actually maybe let's start another one. If I go to, let's see, I think it's just here. Yeah, it's just here. So I should one tensor board. Okay. Oh, okay. Yeah, I need to. Oops, I'm not sure. I remember like the command. Tensor board. Like anyone remember the command?
I think it's just tensorboard, right?
Oh no, I want to load that directory. Okay, maybe I can just run TensorBoard to see if I can load. Have an option to just load the. Yeah, I need to specify that.
Oh, the directory.
Yeah, I forgot.
Oh,
Let's
it's
see.
dash dir, I think. Or
Oh, okay, yeah. I forgot like which one. Let's see. Probably like
or
something like that. Let's see.
I'll
Make
look
it
it up for you.
half prefix. Okay, let's see if I can. I can. Yeah, that's silly. I forgot.
Oh, it's dash dash log dir
Oh, okay. Yeah, yes.
equals.
And for some reason, I don't think it's using GPUs, but it's fine with me. So it's like, let's see, it's saying it's compiling not, is that using now? I guess earlier you say it's not using. So anyway, it's now it's running on a 6066, the port 6066. So if I 6006, oh, okay, so what 6066, right? Oh, I'm probably I shouldn't have local. So, oh, yeah, 006. Oh, why is not running? Where is that? Oh, I already quit. Oh, okay, yeah, that's so silly. Um, so yeah, of course you can. If you go to some tutorial on TensorBoard, there's lots of other functionality. Here, I'm just showing like to visualize the ledger itself. So I have
Is
the
this
website.
new? This
What?
network graph, or have they always had this?
Say that again.
This network graph, is this a new feature for TensorBoard?
Oh, it's always there. I don't know. I'm not so sure actually.
Hmm.
I think it's there like for a very early version. The first couple, yeah, very early. I see that they have that.
Okay.
Yeah. So, but I don't use that much also. But I think it's cool. So I guess it's good to talk about that. So because I see my student using that, it's so cool. Then I guess it's really good to talk about. So I can double click that. It's very nice organized, right? So I can okay, this is what's that. When I get into that, then I can see it's like basically if you remember, like the website is just have like several residual board, right? So this one has like several of the distributed residual board block, residual block, and yeah, this okay. This is just initially doing I don't know, uh, probably there's no downside. Oh yeah, there's a downsampling here. So a simple like conf layer, and then I do a mass polling here, and then you can go even inside. And then the basic block here, like two basic block, and look at this one is also a two basic block, right? And the basic block here. So I believe this is sharing rate. That uh, yeah, this probably is sharing rate. Uh, yeah, maybe not. If it's share rate, it doesn't make sense. Maybe it's just the naming is okay. So inside the basic block, this will be the really a residual block here, residual module. So you have do a conf here. You see I have this this is basically this highway, right? I just like skip all this, I directly go to the output. Um yeah, it's hard to read actually. Well, but it's very nice. You see all the dimensions like given also here. So I have this going to be like 64, 65, 65. This is a 64 channel. Dimension is 56, 56. And then I have a comp layer. Uh, oh, okay. I guess that should be like yeah, I guess it didn't show the other thing, probably a 56, 56 also, like it doesn't make sense, just downsample somehow. Yeah, and then like, yeah, the dimension didn't change, I guess it's like all having padding here. So you have just a simple conf layer, have batch rom here, and then do while loop here, then conf again, same dimension. Yeah, more or less. So I also have like yeah, I'm not sure. Like maybe I should find a conf layer, like put it side by side, and maybe easier to kind of like visualize that. Let's see if I have. Uh, open a CN mm, uh, so we have this simple residual block here, right? So let me make it bigger. Just focus on that one. So we, oh yeah, let's see. Can I move this? Maybe I can zoom out a little bit. How do I zoom out a little bit? Or is, yeah, okay. So let's see, how do I understand this? Oh, this should be the X input, right? That should be X. And then this part is just my website. This is just a conf layer, right? This batch ROM, and then yeah, batch ROM is okay. I can ignore that. So I have like just a conf layer, right? Conf layer here. Then I have another conf layer here. Uh yeah, actually, uh I don't know what this path is. That's if I look at that, this is a little bit weird. There's something like extra that I'm not aware of. Like maybe it's, I don't know. You guys maybe if interested, maybe want to figure that out. Uh yeah, uh of course we can go back to the model and see like in the uh in the basic block there, it just say like a conf layer, give the stripe here, then I have a batch line value, conf layer, batch ROM, and did a down sample here. Yeah, here is actually pretty much similar to here. Um, but yeah, I'm sorry, I didn't prepare for that. Like I didn't prepare to look into, and like many people, like I take for granted, like okay, like the website if we like them, that just call it. I didn't really look into detail like of this individual block, so a little bit uh stuck here. So, but I believe this is not cheating. Like I mean, this is not lying. Like I guess this should be at least the basic will be like that. Like you have this superhighway, so I should be able to find where's that thing here. Um, yeah, but it's actually not easy to really see like well, are you able to find that? Like anyone like able to uh it seems to me it's sequential, right? So where is that connection here to? So, but anyway, like we are out of time. Yeah, but I just want to demonstrate like using this kind of like writing into the tensorboard, then you can export that like the ledger itself like pretty
Yeah,
easily. Yeah.
you know, it's interesting. I've been using tensorboard a little bit, but I haven't seen this computational graph thing, so I need to look into that and see how why I'm missing that. I mostly use it to, just check the training losses and everything. And
Oh yes, there's yeah many people. It has like yeah, it has a lot of like other functionality as well. Like you can do some logging, like put back images. It's a little bit like the weight and biases, I guess, like, for that part.
mm-hmm.
Yeah.
Wow.
Um. So, but okay, I guess we'll just stop here. Then I will come back like next week. Then.
Thank you.
So I'll see you guys.
Thank you, Professor.
Yeah. See you guys.